Welcome students in my educational channel Easy and Simple Physics. Joshi Sir Partur. In this channel we can study the online class for study the 12th standard for subject physics. In this video we have seen the types of circular motion, uniform circular motion and non-uniform circular motion and its applications. Types of circular motion. Speed of particle may be or may not be constant. It depends on speed. There are two types of circular motion. Number one, uniform circular motion, and number two, non-uniform circular motion. So first of all, we have seen uniform circular motion. The motion of a particle or object along the circumference of circle with constant speed, called uniform circular motion. Some characteristics of uniform circular motion can be seen. Number one, in uniform circular motion, speed means magnitude of linear velocity or angular velocity, angular speed remains constant. In UCM, linear velocity changes with change in direction. In uniform circular motion, angular acceleration remains 0. In uniform circular motion, magnitude of linear acceleration is directed towards the center, means centripetal acceleration is equal to v square upon r, or equal to r omega square, or equal to v multiplied by omega. Tangential force, work done, power in uniform circular motion is 0. Radial force is the resultant centripetal force, that is equal to mv square upon r equal to mr omega square, or equal to mv omega. Examples of uniform circular motion. Motion of the tip of hands of a clock. Motion of the earth around the sun. Motion of the moon around the earth. In atom, at center, nucleus is there. Surrounding the nucleus, motion of electron is example of uniform circular motion. In uniform circular motion, the direction of linear velocity is along the tangent. So, the change in position of object, so velocity changes continuously. So, we say that direction of linear velocity is variable, but direction and magnitude of angular velocity remains constant, which is along the axis of rotation. Hence, we say that in uniform circular motion, linear velocity is variable, but angular velocity remains constant. Therefore, due to change in linear velocity, it causes acceleration. So, we say that uniform circular motion is an accelerated motion. But we know any motion which repeat itself with equal time interval along or on the same path called periodic motion. But in uniform circular motion, time period of particle for one rotation is constant, move along the same path. So uniform circular motion is also periodic motion. In non-uniform motion, the motion of particle along the circumference of circle with variable speed means not constant speed. Such motion is called as non-uniform circular motion. In non-uniform circular motion, angular speed and linear speed both changes with respect to time. So, velocity and acceleration are non-uniform quantity in uniform circular motion. But linear speed and angular speed means also kinetic energy as well as angular momentum are uniform quantity in uniform circular motion. The characteristics of non-uniform circular motion is number 1, linear speed, angular velocity is variable or not constant or is different. Second is linear velocity changes due to change in magnitude as well as direction. Third is resultant linear acceleration is vector sum of tangential acceleration and radial acceleration. So vector A equal to vector A tangential plus vector A radial. Tangential acceleration is vector A tangential equal to R alpha, where alpha equal to d omega upon dt. In non-periodic motion, capital T equal to 2 pi upon omega. So, tangential force, angular acceleration, power, work is not zero, is non-zero. Angular acceleration, the time rate of change of angular velocity of a particle or object which performs uniform circular motion is called as angular acceleration. Angular acceleration is denoted by alpha. Therefore, alpha equal to d omega upon dt. In vector form, if d omega vector is change in angular velocity in short time interval dt, then angular acceleration vector alpha is vector alpha equal to limit delta t tending to 0 d vector omega upon dt. So direction of angular acceleration vector alpha is same as angular velocity. As angular velocity omega increases with time, then angular acceleration vector alpha is in the direction of vector omega, so that particle is speeding up. If omega is decreasing with time, then vector angular acceleration is directed opposite to vector omega, so that particle is slowing down. As angular speed of particle changes from omega 1 to omega 2 in time t, then magnitude of average acceleration during this time interval t is alpha equal to omega 2 minus omega 1 upon t. SI unit of angular acceleration is radian per second square. Dimension of angular acceleration is square bracket L raised to 0, m raised to 0, t raised to minus 2. We see the relation between magnitude of linear acceleration, that is tangential acceleration, and angular acceleration, or the relation between A and alpha. We know relation between linear velocity v and angular velocity omega is v equal to r omega, equation number 1. Differentiate equation number 1 with respect to time. So dv upon dt is equal to d upon dt in bracket r omega, which is equal to r d omega upon dt. equation number 2. We know linear acceleration a equal to dv upon dt and angular acceleration alpha equal to d omega upon dt. Substitute the value of a and alpha in equation 2. It becomes a equal to r alpha or at equal to alpha r. Therefore, linear acceleration is equal to radius multiplied by angular acceleration. In vector form, vector a equal to vector alpha multiplied by vector r, or vector at tangential is equal to vector alpha multiplied by vector r. We say that alpha is perpendicular to vector r. Expression for resultant acceleration of a particle in terms of tangential and radial component. This expression can be solved by consider a particle moving along a circular path of constant radius r. In non-uniform circular motion, both angular velocity omega and linear velocity v changes with time. So, particle has both angular acceleration vector alpha and tangential acceleration vector at. Let velocity of particle is vector v and velocity of angular velocity omega vector omega and radius vector r. Therefore, vector v is equal to vector omega multiplied by vector r. Linear acceleration of particle vector a equal to vector dv upon dt, which is equal to d dt in bracket vector v cross vector r, which is vector r d omega vector d omega upon dt plus vector omega vector dr upon dt, where alpha equal to d omega vector d omega upon dt and v equal to vector dr upon dt. So, vector a is equal to vector alpha cross vector r plus vector omega cross vector v. The component vector alpha cross vector r is act along the tangent to the circular path. Hence, it is called tangential acceleration. So, vector at is equal to vector alpha cross vector r. In magnitude, at equal to r alpha. Tangential acceleration at is due to change in its magnitude of velocity of a particle. Therefore, vector alpha is perpendicular to vector r. Another component vector v cross vector omega or vector omega cross vector v is acts along the radius towards the center of circle. Hence, it is called as centripetal acceleration or radial acceleration. So, centripetal acceleration vector AC is equal to radial acceleration vector AR. So, centripetal acceleration is equal to radial acceleration which is equal to vector omega cross vector v. Therefore, centripetal acceleration equal to radial acceleration equal to omega v in magnitude. Centripetal acceleration is due to change in direction of velocity. If a particle is in non-uniform circular motion, then the particle is speeding up. Vector alpha is in the direction of vector omega and vector a tangential is in the direction of vector v. If particle is slowing down, then vector alpha is opposite to vector omega and vector A tangential is opposite to vector v. Therefore, net linear acceleration being the resultant of tangential and radial acceleration. Therefore, vector A is equal to vector AC plus vector AT, which is not radial. Magnitude of radial or centripetal acceleration is not constant. Its example: motion of tip of a fan blade when fan is speeding up or slowing down. In uniform circular motion, resultant acceleration is radial or centripetal acceleration. This can be solved by considering a particle moving along a circular path of constant radius and with constant angular speed omega performs uniform circular motion. Let vector v equal to vector omega cross vector r. Differentiate the above equation with respect to time. We get d vector v upon dt, d is equal to d upon dt in bracket vector omega cross vector r. Therefore, vector A is equal to d vector omega upon dt cross vector r plus vector omega cross d vector r upon dt. Let alpha equal to d vector alpha equal to d vector omega upon dt and vector v equal to d vector r upon dt. Therefore, vector A equal to vector alpha cross vector r plus vector omega cross vector v. In uniform circular motion, as omega is constant, then alpha equal to d omega upon dt is equal to 0. Therefore, vector A is equal to vector omega cross vector v. The resultant acceleration is acts towards the center of circle called centripetal acceleration along radius. Therefore, resultant acceleration is radial. Let us see centripetal force. The force acting on particle performs uniform circular motion which is directed towards the center of circle along radius is called centripetal force. According to Newton's law of motion, F equal to ma. So, product of mass and centripetal acceleration is called as centripetal force. Therefore, centripetal force equal to mass multiplied by centripetal acceleration, which is equal to mv square upon r, or centripetal force is equal to mr omega square. In vector form, vector F equal to minus omega square vector r. So, vector F equal to minus mv square upon r into r0 vector, where vector r0 is unit vector in the direction of vector r. Negative sign indicate that centripetal force vector F and radius vector r. Characteristics of centripetal force. Number 1, centripetal force is a real force. Number 2, it changes the direction of motion of the particle but not speed. And number 3, it is responsible for uniform circular motion, means centripetal force maintains the uniform circular motion. Number 4, centripetal force produces centripetal acceleration. Work done by centripetal force is 0. Number 6, satellite is revolved around the earth in a circular orbit. Therefore, gravitational force between earth and satellite provides centripetal force. And number 7, centripetal force arises in the inertial frame of reference. Second force can be seen, that is centrifugal force. The force acting on a particle performing uniform circular motion which is directed away from the center of circle called as centrifugal force. The characteristics of centrifugal force is, number 1, it is pseudo force or imaginary force. Number 2, centrifugal force is not responsible for uniform circular motion. Number 3, centrifugal force arises a non-inertial frame of reference. Number 4, centrifugal force is acting away from center of circle along radius. Number 5, centrifugal force is effect of circular motion. And number 6, when a bus is moving along horizontal curve road surface, when bus takes turn, then passengers are experienced a centrifugal force. Centripetal force and centrifugal force have some similar points, similar characteristics. Number 1, in both forces, means centripetal and centrifugal, have same characteristics such that both forces acts along the radius of circle. Second thing is, in magnitude of centripetal force is equal to centrifugal force. These are the similarities. One question is there, that is, explain why the work done by centripetal force is 0. We know that work done by the force is work done equal to force multiplied by distance or dot product of force and displacement. So d vector omega vector dw is equal to vector f dot vector s, which is equal to fs cos theta. Vector f is force, vector s is displacement, and theta is the angle between vector force and vector displacement. As the angle between force and displacement is 90 degree, then cos 90 degree is equal to 0. So work done dw becomes 0. Means in uniform circular motion, work done by the centripetal force is 0. We have seen the difference between centripetal force and centrifugal force. In centripetal force, a force which provides centripetal acceleration to a particle to perform circular path. In centrifugal force, a force which explained by assuming the force acting on particle requires to provide centripetal acceleration. Second thing, in centripetal force, a force which is directed towards the center of circle radially. Second thing, in centrifugal force, a force which is directed away from the center of circle radially, means fleeing from center. Third point is, centripetal force is real force, whereas centrifugal force is imaginary force. Fourth point, in centripetal force is minus mv square r into vector r, or minus m vector r omega square, called center seeking force, whereas centrifugal force is plus m vector r omega square or plus mv square upon r into vector r0, where vector r0 is unit vector along the direction of vector r. Magnitude of centripetal force is same as centrifugal force, but direction is opposite. Magnitude is same as application of centrifugal force or use of centrifugal force. Number 1, it is used as centrifuge machine. Its example will be number 1 washing machine, number 2 laboratory, number 3 a cream separator, number 4 in a mixer grinding. These are the applications or use of centrifugal force.